Hello, I'm Nobby. Welcome to my workshop. In my last video, you saw me doing a test on cutting the end caps for the boiler tube. What I did was found a piece of aluminium, roughly the same thickness as the copper I'm using for the end caps, and I made a fixture to go in the chuck of the lathe. This is the fixture I used. I just threaded this 1/4 inch and held the aluminium on here so that I could turn this down to size. That seemed to work out okay. I didn't bother to film the actual cutting of the discs themselves. I did exactly the same as with the aluminium piece. I just cut out two squares, found the centre and drilled the 1/4 inch hole in the middle here, sort of cut the corners off the square so there was less machining to do. But what I actually did was sandwich both of the copper discs together on here and machine both of them at the same time. I guess it was rather a risky thing to do, because if I'd done one at a time, if I'd have messed one up, well, not actually a lot I could have done, but it would have been worse if I'd messed up both of them at the same time. But in fact it worked out okay, and I've got a good fit inside the copper tube here. It doesn't need to be a tight fit, it's got to be a loose enough fit so that when it's silver soldered, the solder can go between the edge here of the disc and the inside of the copper tube. So I've got two of these made. One of them, at one end, has to have an additional hole in it. I don't know if you can see on the drawing, you see it's got the hole here which goes through, which takes the stay, and there's a hole above this. I don't know if you can see this on the planes here. You've got the centre hole here for the stay and a hole here, so that will take one of the boiler bushes, and this is where you would fill the boiler with water. So I've marked up the other disc in the correct position. It's 15mm from the centre here up to the centre of the hole itself. So I've got to drill through that. Now on the drawing, I'm going to deviate very slightly from it. The boiler bushes, it tells you they're 12.5mm in diameter, and they tell you to drill the hole in here 11mm. Obviously when you make the boiler bush, you can make the boiler bushes to fit exactly into here with enough clearance for soldering, but I just felt that 11mm against an overall diameter of 12.5mm isn't actually leaving you very much at all on the edge. I guess it doesn't need a great deal for the solder to hold that in, but what I've opted to do, instead of drilling the hole in here 11mm, I'm going to drill it 10. Just gives me sort of a little bit of extra leeway. I don't really think that, well, hopefully that won't really hurt too much, and the solder is still going to have plenty of room to go through, because the boiler bushes are all going to be made to fit exactly into the holes that are drilled, and I'll make each one individually to fit. So there'll be a boiler bush in, as I mentioned, in the end cap, that's the filler hole, and there'll also be two on the top. This is the sort of edge of the boiler. There'll be two on the top here, one to take the safety valve, and the other one will have the pipe connection from the boiler to the engine part itself. I've already done a test, because I've not done a lot of drilling in copper, drilling the 1/4 inch hole didn't seem to be a problem at all. In fact, I drilled both of these holes on the drill press here, and that seemed to work okay, but this obviously is going to need a much larger drill, so I'm going to drill the hole on the milling machine. I've done a test because there was a bit of copper, or a couple of bits of copper left over from the end cap, so I've done a test here just to make sure I'm okay drilling the hole through. I mean, copper is the strangest thing to machine. I did this dry, as you would drill into brass. You know, whether it should have some cutting oil on it, I don't really know. Obviously this is the purest metal, and it did seem to work okay, and I've got sort of a nice clean hole in here, so I might put perhaps just a little bit of cutting oil on it, you know, perhaps that'll help the drill. So anyway, I've got the other one of these set up on the milling machine already, so I'll bring the camera over to the milling machine so you can see that hole being drilled. Bear with me. Right, we're at the mill. I've got the end cap clamped onto my finger plate. I've shown this many times before, and always, you know, said how useful this particular tool is for holding particularly small pieces of material for drilling, particularly with something like this, because you couldn't really hold this by hand on the drill press or on the milling machine. I didn't want to chance putting this in the mill vise, because I don't want to sort of crush or make any marks on the ends here, so I felt this was the best thing to do, was to hold it down with the finger clamp here. I'm using a spot drill rather than a centre drill, because copper I know is a very grabby material, and I'm rather worried that it could break a drill quite easily. I think these particular drills are a little bit stronger, so I mean, hopefully this is going to work okay, but let's see how we get on. I've already got this lined up on the little mark I've made on here, so let's have a go at this. Right, well, that will give me a starting position. I'll switch this over. I'm going to use a smaller drill first before I go with the 10mm drill. And hopefully this will work okay. I'm not covering up the camera while I'm doing this, but let's get the drill nice and tight. And I use just a little tiny bit of cutting fluid on this. Whether that helps or not, I just don't know, but I guess it can't do any harm. That appears to have gone through okay. I've got the finger plate mounted onto a piece of wood as well, just to raise it up a bit so that there's no danger of me drilling into the bed of the milling machine, which would be a disaster if that happened. 10mm drill. This is just a very ordinary 10mm drill. I looked through all the drills I've got, and I've not got any sort of special real quality drills in 10mm, strangely enough, because I guess 10mm is not a size of drill that I use very often, to be honest. So we put another bit of cutting all around that. See if that does help things along. Right, keep your fingers crossed. Yeah, well, that actually moved. Right, I'm going to come back to that. I'll just switch the camera off just for a moment just so I can line that up. That's obviously move this under the clamp. Bear with me. Well, let's see how that goes now. I took the drill out and I used the smaller drill to find the centre again. It looks okay. I think it, being a gummy material, I think it has grabbed the drill, so I'm going to have to be very, very careful drilling this now. So let's see what happens this time. I think I've got that. I appear to have that lined up okay, I hope. Let's see how we get on with it this time. I've tried to tighten up these clamps as tight as I possibly can. Hopefully nothing will move this time. Let's have another try. Well, hopefully that's okay. I didn't get as much of a burr this time as I got on the test piece I did. So let's take this out and give it a clean up and see how it looks. I think I've got away with it. I've just measured it with a digital caliper. It has cut oversized, over 10mm, which perhaps that's to be expected, but I think the whole is actually reasonable, and I'm glad now that I didn't go for a bigger drill size, because if I'd have used an 11mm drill and the same thing had happened, it would have been, I guess, too oversized for the material I've got to machine the bushings. So hopefully that's going to be okay. We'll soon find out when I start machining the bushings, I guess. But I've cleaned it up on both sides, just sort of deburred it round. So fingers crossed that's going to be okay. So basically the end caps are completed now. That's all that's required on those. So I think what I'll probably do next is cut the stay to length, and then that basically all that needs is a thread on each end, and the stay is held into the holes here with a little locking nut on on each side. Again, made out of bronze, but they'll hopefully be quite easy items to do. Anyway, let's move on. Well, something just to mention, when I was drilling the hole here for one of the boiler bushes, and the drill obviously grabbed onto the copper, and I very nearly completely ruined this part. I think I've just about got away with it. It sort of looks okay, I think. Something that just didn't occur to me at the time, and I know that there's someone out there that's really going to moan at me and tell me off for not doing this, but I'm guessing that drilling copper is it being even worse than drilling into brass, where brass can grab as well, that you should modify the cutting edge of the drill. I don't know, it just didn't occur to me to do this. So that's probably what happened here. It was okay on the test piece I did, that seemed to be okay, but perhaps I was just lucky with that part. So once I sort of reset this into position again, before I drilled the hole right the way through, I used a stone to take the sharp edge off at the ends that were the cutting part of the drill itself. Should have done that. Should have remembered that. Obviously, it's rather stupid of me not to have done that in the first place. But there we are. Lack of experience, really, particularly in working with copper. I did remember this on the previous job I did, where I was drilling quite a small imperial drill, and I'd stoned off the sharp edges here, so to remind me that this drill has been altered for brass in this case, I put some yellow, I think this is yellow nail varnish or something like that on the end of the drill here, so that I can remember that this one has been, if you like, modified specifically for brass. And I'll do the same with this one, and keep this one on one side for future use on brass or copper. I mean, I'm going to have to use this on the boiler cylinder itself to drill the two holes in the top here for the other boiler bushings. Should have remembered that. But anyway, the next job I'm going to do is make the stay. The stay mounts through these holes, and it's threaded on the end here, and you have a little bronze nut on each side here to hold this in position. So this I guess the function of this, I imagine, is to hold both the end caps in position, and hold them sort of nice and square to the boiler, so that they can be, I guess, entered through the boiler, and that will hold both of these in place inside the boiler while that you do the silver soldering. Just look at that. That's a 1/4 inch hole. This is 1/4 inch copper. Obviously, it's tight into that hole there. It would be a hard press fit, but of course, once the thread's been cut on that I know that will go through quite happily. They say that you can make the stay a bit longer than required. You can then later on, I guess it would need to be filed, file that down to length. So I'm going to just have to sort of try and estimate what length this needs. I guess if you make the threaded part longer than required, that doesn't matter, because that that part of the thread's going to be inside the boiler anyway. So this, obviously I'll put this in the lathe, and I'm not going to immediately cut this to length. What I'll do is I'll cut the thread on one end first, just in case I have any problems, because I don't think I've ever cut a thread on copper before, to make sure it works out okay. That the die I'm using here, in fact the stay nuts and the thread that it goes through the middle of the boiler bush are all 1/4 by 40 ME. Obviously a very, very fine thread, but bearing in mind that with the stay nuts they are only 3mm in thickness, the same thickness as the boiler end cap, so being a nice fine thread obviously is going to give you good thread engagement on the stay nuts. There'll be the stay nut on the inside and outside of the end cap. The drawing doesn't give you any indication of what length this needs to be, so I've just done a few measurements, and I think it needs to be 112mm long. But what I'll do is I'll set this up in the lathe, cut one thread. If that works out okay, if I obviously have any problems, I can start again. If I cut this to length first, I can't start again. So I think that's the best way to proceed. So bear with me, and I'll set this up in the lathe and just show you, not very interesting, but show you the cutting of the thread on the end here. Okay, well I've got the piece of a 1/4 inch copper bar mounted in my collet chuck. This doesn't get used as much as it should. I bought this quite a long time ago, actually for my Chinese mini lathe, because the plate that this comes on is this part, if you like, is the collet chuck, and the back of the plate has the register for the chuck plate on the Chinese mini lathe, so this fitted directly to it, and the object was to use it really with that particular lathe. But what I decided later was to buy a Myford back plate and machine the back plate to take the register of this collet chuck. It's not bad. In fact, it's when I put the piece of copper in here, I did use a clock gauge against it, and it's about 1/1000, just over 1/1000 out. But that is better really than any of the chucks I've got. And I thought that perhaps using a collet chuck on the piece of copper would be less likely to damage the copper in any way, although you're not going to see it because this is going to be inside the boiler. What I want to do at some point is buy a proper collet chuck for the Myford lathe. There are, not the Myford one obviously, because the Myford one, the collets for that are incredibly expensive to get a genuine Myford one, but there are some Chinese or Indian, I think perhaps Indian made ones made by Soba, which will fit directly to the threaded nose of the Myford. I think the ones that I've seen use slightly smaller collets, and this one takes ER32 collets, which I chose this one because I already have a lot. Well, the only collets I've got are ER32, which I use on the milling machine. So that was the reason for buying this one originally. This was before I had the Myford lathe. The Sober one, from memory, takes ER25 collets. It is quite expensive, so it's not something I can buy immediately, but you can buy it as a kit, the collet chuck with a set of collets, and the locking spanner comes as a complete set. But that is perhaps something I'll get at some point in the future. Thing is with this one, it is, the back part of this is quite large. It doesn't really matter, but the sober one, the dimensions here are about just a bit over this sort of dimension, so it is much more compact, much smaller. This one has in the plate, on both sides, it has a little hole which you can put a Tommy bar in to hold while you use the usual spanner to tighten up the locking nut on the outside. I just had to find a piece of quarter-inch material that would fit into it, so I can hold that while I tighten it up. But I think that's going to work all right. So what I'll do is I'll just clean up the end of this, put a little chamfer on it, and then we'll measure out the length I need and cut the thread. I'm using a carbide insert tool because I discovered that seemed to work better than the high-speed steel tool on copper. Whether it makes a difference on this piece, I don't know, but I did get a better result when I was cutting the end caps by using the carbide insert. Just needs a little bit more. It's not quite cleaned up yet. It just needs a little bit more, actually. That's better. Right, we'll take that off and we'll put a chamfer on there. That's it. Looks okay. Let's get that out the way. Right, now we can switch the lathe off and release the belt so that can be turned. I'm hoping that I can cut the thread on this just by turning the collet chuck round. The other option is to make it easier, a long time ago I made a winding handle. Probably seen these before. There are Myford ones that I gather, but this is one I made. I originally made one of these for the Chinese mini lathe, and this basically fits in the other end of the headstock through the hole in the shaft of the headstock, and you've got a little screw on here which draws this cone piece back, and you see it's got little slots cut in here, so as you wind that back it expands the end of this and locks it inside, so you can then use this to turn because it's a nice long handle, you've got a lot more leverage to turn the chuck round. But I'll see how I get on by doing it by hand. If not, I can fit this in and use this to wind this round. Now I'm using my die holder here. This is a set that I've got, which you can use for all sorts of different sizes of dies. This takes the small 1-inch ones, and it takes a slightly larger one here, and there are 2 adapters that go in this to take even bigger dies as well. And it also takes this device, which could be mounted inside here, so that you can put taps in it as well. And there's 2 of these in different sizes, so it covers the whole range of taps as well. And this fits onto this arbor, which goes in the tailstock. I think I've shown this before, but just so you can see what I'm using to do this. Right, let's bring the carriage right forward and I'll bring this up. What I'll do first is mark the length that I need on this. So I think I mentioned I was going to make this about 12 millimeters long. I think that's what I said. So we'll put a little mark on there with a Sharpie. Doesn't matter if it's a fraction longer than that, it's not going to make a great deal of difference really. Let's make sure I can get that between the, put that in, and there's a little handle that goes into here, gives you something to hold while that's going there. I just lock the tailstock and we'll draw that in, and we'll cut our thread. Backing it out to actually, I think that that's actually moving the copper bar in the chuck. I probably didn't have that in tight enough. Yeah, it is actually moving that, so I think what I'm going to do is back that right off. It is actually turning the material. Bear with me a moment while I get this adjusted. I've actually fitted the hand at the back of the headstock because this is a bit hard on my hands. My hands are not very strong nowadays, so I'm using the winding handle. You see this is moving round remotely. I did unthread this completely just to make sure that it's cut the thread okay. Well, it looks as though it's cut it okay anyway, but using that handle is a lot easier, and you can keep sort of winding it back to break the swarf off, because it throws up quite a burr. Nearly there. As I say, it doesn't matter if it goes a little bit over, just give it another little bit. There we are. It's such a fine thread, it really is. Just take that back a bit. There we are. Well, it is a very, very fine thread, that. But it's done it. So it's quite sharp, so I might have to just very, very gently run a file over that. Now, if you make yourself one of those winding handles to use in the back of the headstock, whatever you do remember, as soon as you've finished with it, take it out, because if you start the lathe up with that handle still in the back, it's going to spin round. It could easily hit you, and it will shake the lathe dreadfully. Believe me, I know. So that's the handle removed. You just to release it, you just back that off a bit, and then just tap that with a rubber mallet, and that will release the little cone bit, and you can just pull that out. But it's such a useful tool to have for your lathe. So that looks okay. So it's just I'll just show you that part. Very, very fine thread there. I'll just obviously do a bit of cleaning up, and then I'll just cut this to length and thread the other end. I won't bother to show you that as well, because it is just a repeat of what I've done here. So there we are for the moment. Something I forgot to mention before I cut the thread on the other end of this piece of copper stock, I just put a file over the end here to take off any burrs on the end, and very gently ran a very light file across the top of the threads, because they were very, very sharp. But I forgot to mention, I did make like a little test piece, just to make sure that the thread is okay, because it is a very, very fine thread. I did look at it through a magnifying lens, and it certainly looks okay, but I just made this out of aluminium with the quarter 40 thread on the inside, and that, if I can get it to start, all fingers and thumbs, and that goes on quite nicely. So that was just basically to check that the thread is all right before I commit to cutting the piece of material down to size and cutting the thread on the other end. That's a little bit wider than the actual locking nuts are going to be. They're only going to be 3mm wide. I think that's 4mm. So there'll be obviously one here, then there'll be the end plate, and then another one of these on the other side to lock it in position. So I thought I'd just show you that as well, so you can see that I did make this little test piece, because I haven't, in that size, obviously I don't have any screws or nuts with quarter 40 threads on them. It's it's a very, very unusual size. I mean, I have used that thread size before, but for sort of other applications, so I didn't have a nut that I could actually try on it. When I made the arbor to cut the end caps, obviously this was a BSF thread, a quarter 26. Obviously I do have screws and nuts of that size, so obviously I could easily check that was okay. But, yeah, just for your information. So So that's it. So off camera, I'll just cut this to size, and I'll put a thread on the other end. Won't bother to show you that as well, but obviously in perhaps the next video I can show you the stay actually assembled onto the end caps, perhaps in the next one. So I'll round this video off now, and hopefully bring you back for another video pretty soon, you know, showing some other parts. I think the next things I'll be doing is I want to get all the parts made for the boiler, so the next bit will be making the boiler bushes. What I think I'll probably need to do actually is to drill the holes in the copper tube first, so that I can make all the bushes in one go, and make sure that each individual one fits sort of nicely into place in the top of the boiler and in the end cap, which has that extra hole in it. So I think that will probably be for next time. So thank you very much for joining me in the workshop. Thanks again for all the nice comments that I'm receiving as well, and thank you also for the advice that you're giving me on various operations that I'm doing. That's all very, very useful to me, and it is helping me a great deal. If you have not subscribed to the channel, please do. And if you'd like one of my workshop stickers, my email is in the description of my channel. You know, just pop me an email. I'll be happy to post a sticker to you. If you want to do an exchange, that's great as well. So that's it. Bye for now. Bye bye.